Good morning, everybody. Happy to have the first talk here today on the WeAreDevelopers, and my talk will be about tracking and traceability opportunities and with privacy aspects in the industry. I'm a researcher at the US St. Pölten, and yeah, if you have questions, please ask, because it's a huge topic and we should all have more a discussion like a just talk from me. Okay, some words about me. I'm working on the US, as already said, and I'm working in a research group that's called Digitech. What we do there is looking with industry partners to implement new technologies like VR, AR, or like my work is try out tracking systems in the industry and look where's the problem and how we can solve that. So I'm making the PhD actually on the TU Vienna, and yeah, therefore my topic is also employee privacy versus tracking systems. So what we will hear in the next 30 minutes, we will talk about traceability applications, where they can be used or where they are already used, like industry, healthcare, agriculture, and infrastructure. We will take a look on tracking technologies and radio standards and benchmarks, how to compare those systems. And third point is we take a look at indoor location methods, so how these technologies are used to find the position in a room. And last but not least, we will take the course into privacy versus traceability, because this topic is already my PhD topic, and there's always two aspects. So the one aspect is that tracking systems have relevance and are already used, and they bring benefits, of course. But there are also challenges to solve, because if I use tracking systems in industry, it can't be attacked the privacy of the employee or the customer or anything. Okay, so let's go back. Let's go back into year 1983. There was RFID was just developed, so it was broadly brought into industry, and the industry tried to use it for their benefit. I think everybody knows what RFID is. So RFID is a mostly passive use technology where you can identify, that you can use for identification systems or tracking. And what did this enterprise in 1983 tried was an access control for the employees to have to know if the employee is here or in another room or outside the building. So of that's okay, but they also track the toilets. And in the toilets, you may say that's really a privacy aspect which is not possible. So, but they tried so they tried it to find out which woman is pregnant, so which female employee is pregnant, and they did it like that. They had an algorithm and said, okay, normally women go twice a time to the toilet, and if they go more often to the toilet, then they have their menstruation phase. And if they have no menstruation phase, they don't go so often to toilet, then they must be pregnant. And that was really an impact, because before the female employees could say, okay, I'm pregnant, I have to go in maternity leave, they already was fired. So That was 1983, and you know, there was no control any because the technology was so new and things like that could happen. I will not say that this happens actually, but just the fact that it could happen is the fact to talk about. And so if we use tracking technologies, we always have to be aware that things like that could happen. And if not the actual enterprise leader does it, maybe the next one uses data. So just to get an overview of traceability in the industry, what happened the last year was what has impact into that. So RFID was developed in 1975, and that the thing I spoke about was 8 years later, which no control anyhow. 2010 Bluetooth 4.0 was coming up, and Bluetooth is also a big player when it comes to tracking technologies. We will come later on to it. In 2012, everybody said, okay, wow, we need now Industry 4.0, which is just maybe a keyword, but the awareness was already there, and then a lot of data was a lot of data come out of these systems, but nobody cares about already. And then we had the GDPR, and so that the answer is, or the question is, where are we now, and what guidelines have we now today? So when I talk about tracking technologies or tracking use cases, I mean objects or employees or persons that have a digital beacon or tag mounted on them, and which shows which saves the location or the position of them. And I don't talk about digital tracking or some workflows with documents in the enterprise. So the four big application areas are the infrastructure, of course, because we know all very well GPS and we use it already every day. In smart manufacturing, so on the shop floor, it's also used actually, but not in that. But there are not so many use cases actually. It could be more. Why this doesn't happen, this wide area application, is I will come to later. In agricultural, there's also RFID mostly used to track the flow of the livestock monitoring or inventory management. And one area where tracking is already well implemented is the healthcare topic, because there there's a lot of stuff, there's a lot of tools. And if you think about when we're in a healthcare center, the staff needs to know where the doctor is, or they need to know where the patients are, because everybody knows the case. You're locally in a healthcare center, in the hospital, and you go out of the door and just say, oh, you cannot go out because the doctor wants to see you. And so they lose a lot of time to search for people or inventory. Okay. So how could this look like? So we have here the hospital environment where we can track stuff like a doctor or a nurse, or a doctor needs equipment and he knows actually, can look on his tablet, where is the equipment I need actually. And also on every door you have maybe an RFID reader. When you go through it, the system knows that you left the the room. Where tracking can be used in industry is like here. Um, there are a lot of different orders, like we see these parts, and they have all different numbers, and mostly they have about, I don't know, 500 or 1,000 orders in work, and there to find the right order is always a big challenge, because the parts look all like the same, but you don't know which is one, and so there's a paper on it where the order number is on it, but to find the right thing, it's make you cost a lot of time. Or in the worst case, you lose an order and you cannot find it anymore. So one company partner said to me one time, before I'm looking for that lost orders, I reproduce it. So I don't think that's the right way to get into it, but it's actually it's made like that. And of course, in warehouses, if we find the right order that you are looking for, you can save a lot of time. But all these cases can also get some privacy data from employees, and therefore is to say maybe in healthcare it is very good developed that they look on the privacy actually, because they already do a lot of people tracking or employee tracking. So they think much more about privacy like industry does. Okay, so which technologies are used now? So this may be a nice overview of systems or technologies that are used. So we have the blockchain already, but the blockchain cannot stand alone as tracking technology, because you always need an communication system. So the last years the barcode developed, but I will talk today mostly about this part, where we can see the different technologies that are already used. So we have Bluetooth, we have 4G or 5G, anyway GPS, Wi-Fi, Zigbee already. What's not on the list is LoRaWAN, so low range wide area networks. And as you see, these are all technologies that we use. Some of them we use in our cell phones. So that is always the question, that these systems also can track my cell phone. So always be aware of that. And the enterprises that use that systems mostly don't take aware. Yeah. Okay. So this is a typical architecture of like these systems are developed. So we have a beacon. In that case, we have a Bluetooth beacon that does nothing more than sends his MAC address instantly every second or 10 times a second out to get a connection. And this technology is used for tracking, because you don't need a connection to the Bluetooth tag. You just need to know where he is, and you know in the receiving node you get the signal strength of it, and so you can locate it. And mostly in common systems, there we have a cloud service, and there is the calculation of the position of this tag done. So we always have a lot of receiving nodes and much more beacons. So the receiving nodes are mounted in the room that I want to track, and the beacons are mounted on the containers or on the stuff. And this data all goes up to the cloud, mostly because the common system earn money with that. And they will not make much money if they just sell Bluetooth beacons or receiving nodes. And what the enterprise does is get this data back from the cloud and put it on the server and provide it for the client or for the database. So there may be much more other architectures, but this architecture is one of the most common for system out of the box use. Okay, so and how does we calculate these positions? Because we just get normally an ID, so a MAC address or anything, and we get a signal strand, and with that the system has to calculate the position of my tag. So we have location tracking is the easiest one. You just say, just have 4 receiver nodes mounted in my room, and I look where is the signal strand, where is the highest signal strand, and in this place is my tag, so my container, and this is the easiest way. You have no algorithm or just an easy algorithm. Then with radio standards, we also can do triangulation, fingerprinting. I will describe this on the next slide because it's just an overview now, and it's easier to understand if you see the images to that. So we have triangulation, fingerprinting, which also can be used for Bluetooth, Wi-Fi, low range. Of course, everywhere is machine learning in it, and so this is not. This slide is not showing that just only one of these technologies can be used in the system. Normally, you have a triangulation and a fingerprinting together, or machine learning and fingerprinting, so you can combine to get better results. And what's actually a very new technology, so the technology is not new, but it's new in Bluetooth 5. It can be used there since 1 year, I guess, is angle of arrival. That means I can get a direction out of my receiver node. So in that case, in triangulation or location tracking, I just get a signal strand, and here I get also the angle of which the signal is coming from. Then ultra-wideband systems use time of flight. Sorry. And this is much more accurate than the others. And also GPS uses it. But I don't want to talk too much about GPS because GPS is already good known and we use it outside. But why we need those systems inside, indoors? Because GPS is not working inside. So if GPS works inside, I could not talk today about it. Okay. So here we can take a look at these on these techniques or methods again. With an angle of arrival, I have on my receiver an array of Bluetooth antennas, and this is like mounted like that. You have 4 antennas, maybe, or 2 here, and 2 on the other side, and the signal, like you can see here, maybe you see it better, there are a lot of antennas on it, and they all get the same tag ID, and then they calculate like that how the wavefront is coming into the system, and then they can decide, okay, it's about 40 degrees or it's about 30 degrees, and that calculation is much more accurate because I always know which angle the signal is coming from. So time of flight, just counts the time that the signal takes to my tag from the receiver node, and it can comes back then, and so I can now I know the time, how much it took, and so I can calculate how far these tags are away from me. Maybe you heard about it that iPhone 11 already uses ultra wideband. They have the chip inside, but it's the only phone that has this implemented. They want to use it for some tags or to find your key, something like that. But it's not clear if in already rolled out ultra wideband systems that the iPhone can be also found. So maybe the next privacy challenge is arising there. So, and then we have the fingerprint technology. So that means that I have to measure my room, and I get the signal strength from every node like that. And on every place, I have different signal strengths from all my receiver nodes. And if I want to know where my item is, I just have to look in the database where this normally, when I have this data, this signal strengths from my receiver nodes, where could it be? Works very well, but if you change the environment, you have to remeasure the room. And last but not least, so triangulation method. So these are my receiver nodes, P1 or P3, P2, and the circle is the signal strength, because normally I don't know where the signal comes from, and so I just need at minimum 3 receiver nodes to calculate this position, and where the circles meet, there is my item or my object. Okay, so how can we now get an overview if I want to implement those systems? Which system fits best for my application? As said, there are a lot of technologies. There is already no standard, and it always depends on what my application is. So no one can say this is the best system for every application. And to get an overview what benchmarks are necessary, or what are the most necessary benchmarks to look at is the availability. That means, do I need some new infrastructure, or can I use the already infrastructure that's implemented in my environment? The costs are always a big topic, and there we have a lot of different costs in the different technologies. The energy efficiency is the next one, because it makes it different if you have 10 tags to observe, or you have 2,000 tags to observe. And normally the price range is about between, I would say, 20 to 100 euros per tag. So if I buy 1,000 euros, you can imagine that it's not so cheap. And what also comes with that is the maintenance, because if I have to maintenance 1,000 tags, I don't want always to change my battery every week. And then I have the range is also the next topic. Do I need do I have a small environment or a big environment? And accuracy, of course, would be nice if there's one technology with everywhere 3 diamonds, but actually we do not have it. Okay, so what's interesting in here is ultra wideband you have to build your own infrastructure for that. The costs are very high actually, so we speak about 100 euros per tag. The energy efficiency is okay. You can talk about 6 months, maybe with good tags. And the range is okay, about 10 meters or 20 in good systems, but they have a very high accuracy, so you can really check it. You can really say at an XY position where my item is, and the accuracy is about 10 to 30 centimeters, and this works also in 3D. So Wi-Fi is also an interesting technology because normally you have a Wi-Fi network already installed in your environment. The costs are not too high like Bluetooth, but one thing about Wi-Fi is that the energy efficiency is not so good, so you have to maintenance a lot. The range we know already is also good. Accuracy is also better than Bluetooth. What leads to the next technology I want to take out of this list is Bluetooth. Bluetooth, it looks like that they're getting better for tracking application, but already what it didn't solve is the accuracy. Maybe it gets better with angle of arrival technology, but then the costs would be also higher. Okay, so an RFID is widely used because it's easy to implement. It's cheap because the tags cost about 50 cents or something like that. I can put it on stickers. I don't have to watch it. I don't have to maintenance it because mostly they have no energy consumption because they're passive. But the problem is I don't have a very wide range, so maybe 5 meters, and the accuracy. Yeah, I cannot do. I cannot calculate it. I just can say, okay, my tag was running through this receiver node. So we see a lot of technologies, benchmarks here, and not always easy to find the right system, and it's not. You don't have always the money to try every technology in every use case. Okay. Okay. So, how long time do I have? Okay, thank you. 70 minutes? Perfect. Okay, so that was the overview about technology and how these things play together actually in the industry or in the application areas. So now let's have a look at the challenges, the unsolved challenges. As said already, the scalability is always a big topic because you can run a tracking system with 10 tags or 100 tags, it's no problem. But if you have up to 1,000 or 2,000 tags, it gets a lot of more difficult. So you need a high investment. And the benefit for every company or enterprise is not so clear actually. Then one next thing is the lack of standards. As I said already, many technologies are used, but you can actually not say which standard will be used in the future, or maybe ultra wideband gets cheaper, then we will have a standard because it's now in the iPhone, and maybe this takes an impact on the price, maybe, or other smartphone providers use also this technology, and then maybe they can define a standard. Of course, the next thing. Oh, sorry. The next thing is the energy efficiency. You always have to take care about how high will my maintenance costs will be. You cannot say, I'm changing the battery every week of 1,000 tags. The costs, I said already, and one thing that's very interesting for me, because I think that's a challenge where we have really take care, because when we track objects, also stuff could be tracked. And there are no real guidelines actually how we could work with that. So what is the big problem with the privacy aspect in tracking systems is that mostly the enterprises try something out and they say, okay, let's implement some tracking system because we see those benefit, and then they take a common system because it's not necessary to develop out of your own. And then you don't know where the data will be stored, because it's all stored in the cloud, as said already. And the employer has the responsibility for the employee's privacy, and they do not be aware of that. So maybe topic could be like most of the access points providers provide also location tracking for their access points, and they say they are privacy safe, but not always it's done like that. So the employer can get real sensitive data, like positioning data of an employee, or data from a smart card. And in the worst case, as told in the story and at the beginning of this talk, tough decisions are made by evaluating illegal data. And so we should take care about it. We should try to avoid this worst case already. So maybe I take one. Okay. So how can we avoid these situations? So one big impact could be that we use these privacy by design aspects or strategies to avoid cases like told in the story at the beginning. What is privacy by design is, many of you will know that, but it was brought by Enka Wukian in 2010, and they say privacy is not a feature, it's not an add-on, it's the fundamental architectural principle. So that means before I go into my interface decisions or my data transmission or storage decisions, I always take care about the privacy aspect. We will come to it later, and it's already regulated in the GDPR, and there it's in the Article 25, the data protection by design and by default. So these rules are implemented in the GDPR already. So, but as you can see, it's a very good orientation to work with that in your system architecture, but it's very common, it's very generally. So you always have to think about what is meant by that. So in short, we have the first principle is proactive, not reactive. So that means avoid privacy issues before they can happen. Privacy as a default setting means, in principle, that you, if you can do some settings, you always has to implement the default setting, the best privacy settings you you can provide. Privacy embedded into design, of course, it's not an add-on, it's fundamental. And end-to-end security, of course, yeah, we see visibility and transparency, respect for user privacy, and that's all clear for us because we do this job and we know about this. But the question is it always implemented in our process? Because we have to do it. So let's go one step further. So of this general strategies, Hopman designed privacy design strategies, which makes a little more clear. First, I have to say there are a lot of frameworks that provide these implementation strategies, but it would take too much time to talk about them all today. So if you're interested in how to measure the privacy in your system, you can write me, of course, so I can give you some tips. And Hopman took these 7 principles from Cavoukian and defined it in more usable strategies. So that these are minimize, hide, separate, aggregate, inform, control, and enforce. So what is meant by this? So minimize always says take only as much data as you really need. That means that you don't show data or store data that are not used for your process, like in industry, or you save the data only just for 10 days or something like that. Hide means principally, of course, anonymization technologies, encrypted processing, encrypted data communication, and storage, encrypted storage. And separate means that you should reduce the granularity of the data, because I always can save the data, store the data like an XY position, or I can save the tuple he was in this room. And the higher the granularity is, the more impact is there on privacy, the more recalculating I can do with this data. Aggregate means that you eliminate raw data. So like when I talk about Bluetooth tracking systems, they also get the data from our cell phone. And you have to avoid that this could not happen. And if I have a whitelist where I just store these tags which I use in my tracking system, I can avoid that I took all of your cell phones in my database, which goes to the cloud, and I don't know where what happens there with it. Of course, inform data, so inform, so be always transparent, show which data do you save, which data is processed, and what happens with the data. So an employee always wants to know, so if you need to track, then what is tracked from me? And of course, control, so the employee or the user should always have the control about the data, and of course, we should all apply legal requirements. So that's from my side. I say thank you for the talk. It was very nice to talk today, and I hope you liked it. So now we open for questions.
Okay, so thank you. So thank you very much for the talk on privacy. So we can spin up our questions. We got quite a few of them. So Alex wonders if the usage of real-time about the usage of real-time data and how that might be used commercially. I guess a lot of people would be hesitant towards that. what's your take on this? She's referencing the first example you gave.
Okay. Okay. Why this? Hmm. Why? Yeah, maybe if you when I come back to use case to a healthcare center, you get an RFID band on your hand and you tracked where you are. So this helps the healthcare center and to find the persons or the doctor.
So you think that's maybe forced on the employees, or is that?
No, it should not be forced on the employees. You should always have an opt-out opportunity. But we always have to think about is the use case can we bring some benefit in it, and what's on the other side, what is the effect to the privacy? So there are cases where tracking is good, like in dangerous work scenarios, like you're working in an atom reactor or something like that, and you like to know that your employer knows where you are, because in case because when it gets dangerous, they should find you. So these are two. That is the thing we should talk about. Yeah.
Yeah, I think the really big area of questions around privacy is also, is my data, is the tracking going to be abused? And that's also the point of our next question. So we have the technology, and apparently the security from being abused by this is not sufficient, or at least Alex thinks that. What's your take on this?
Okay. Yeah. How easy could any technician use and abuse it? How can I? Yeah. If you so, it's necessary to think about the privacy by design framework, and just test your system to these rules, and then you can say, okay, but maybe that didn't come out that clear, because there are other frameworks to test the privacy that go much more into detail, but it's easy to use, and yeah, maybe you write me a mail and I give you that framework to look at it, if you can use it.
All right, thank you. Another question about whether you can give us an overview of what you think. What can a person actually do to protect oneself from abuse?
Okay, yeah.
In the area of tracking.
So actually, if it's right implemented in the system, in the application area, like actually the Flughafen airport in Amsterdam does this tracking for indoor positioning or indoor navigation, and they all have there, if you go there, you have always the signs and the standing, okay, here we track Wi-Fi and Bluetooth, and I think that's very good, because if I know I get tracked, I have the opportunity to not be tracked, because I can shut down Bluetooth or Wi-Fi. So actually, I would suggest don't use an Wi-Fi in the enterprise, and you don't need always Bluetooth enabled.
So there should always be consent about this. You as a person should have the opportunity to decide if you go for it or not.
Yeah, and when it's done anywhere, you should be informed.
And so I think you partially answered the next question. Or can it be, or will it be forced?
I talked.
I think it's different when we're talking about employee or when going to an airport. But
of course, but it's same, because it's the same data. No, not just the question is what does the airport with this data, and what does my employer with this data? So normally you should be informed about that, or you should be able to opt out. And if it doesn't have this opportunity, then it's a thing for the justice, because actually you are not forced to be controlled by an employer.
All right, thank you. It seems we're getting out of time, so
Okay.
thank you so much for your talk
Okay.
about privacy. I think this topic sparked a lot of questions. So in case you have more questions, feel free to reach Christian
of course.
off the stage. And thank you again for your talk. So give a round of applause for Christian.
Thank you.